Membrane excitability. To understand how excited a membrane can be, and I know you're excited too, to learn about membrane excitability, what we really need to look at the current changes across any particular membrane is you need to use a recording electrode. Simply, you put a recording electrode on one side of the membrane and then on the other, or you put it inside the cell and then ground it. The potential across the membrane allows for some signals to potentially be sent. And interestingly, the signal between, or the difference between the membrane and the outside of the cell oftentimes has a voltage potential. This voltage potential is determined by the ion concentrations inside and out of the cell. So by knowing the ion concentrations, you can get insight into this voltage change. How does this work? Well, you need to know a few things. So I'm going to use a couple theoretical examples first, and then we're going to go into some practicals. Theoretically, if we had this bath, and we had a divider in the middle of the bath that didn't allow any ions to travel through. Let's just label one of them ECF, which is representative of the extracellular fluid, and ICF as representative of the intracellular fluid. You put an electrode on one side, electrode on the other side of the bath. In this case, we're using potassium and chloride. In our example here, the number of positive and negative charges is equal. Now I know if you're looking at these two baths, you're telling me, how is that equal? What I'm saying here is the number of positives equal the number of negatives on both sides of the bath. Not that the one side of the bath has a lot more molecules on than the other. It's just the sum of the charges that is important, not that particular ion number. So when there is no charge imbalance across this particular membrane, there's no voltage. So even though there's a different number of ions on one side than the other, there's no voltage. Let's now contrast that in another condition in which the membrane between the baths now have little channels in them. And these channels are going to allow some of the ions to travel through. And let's say those channels were selective enough to only let the positive charged ions through. Yeah, it's exactly what you would do. You're only going to let positive people through the door into your bath. You're going to keep the negative ones over on the other side. If you have the positive charges go to one side, if you're recording in the opposite side, you'll have more negative charges there, and so membrane potential will decrease if you're looking at it from the ICF side. If you were looking at it from the ECF side, membrane potential would have increased. So it matters where your recording electrode and where your reference electrode is located. If your recording electrode's in one side, you'll only be able to determine the changes in that side in comparison to the other.